Orbiting Jupiter are four of the most extraordinary moons in the solar system: Io, Europa, Ganymede, and Callisto. These Galilean moons, discovered by Galileo Galilei in 1610, are not mere satellites. They are complex, dynamic worlds in their own right, each one unique in its geology, composition, and scientific potential. At Infinity Beyond, we often say that if you want to see the diversity of planetary environments, you don't need to leave Jupiter's neighborhood. Let's begin with Io, the innermost of the Galilean moons. Io is the most volcanically active body in the solar system. Its surface is a chaotic landscape of sulfur plains, lava lakes, and erupting volcanoes. These volcanic plumes can rise hundreds of kilometers into space. What drives this incredible activity is tidal heating. Gravitational forces from Jupiter and neighboring moons flex Io's interior, generating enormous friction and heat. Io has no known subsurface ocean, but its volcanic processes offer insights into the internal dynamics of rocky worlds. Next is Europa, perhaps the most tantalizing moon in the search for extraterrestrial life. Covered in a smooth shell of ice, Europa conceals a vast subsurface ocean, one that could be as much as 100 kilometers deep. This ocean is kept liquid not by sunlight, but by tidal heating. Europa's cracked and ridged surface suggests that the ice is dynamic, moving and flexing as the interior warms it from below. Observations from the Hubble Space Telescope and the Galileo spacecraft suggest that water plumes may be erupting through the ice, offering a direct path to sample the ocean without having to drill. If microbial life exists anywhere in the outer solar system, Europa is a prime candidate. Its ocean may be in contact with the moon's rocky mantle, potentially enabling hydrothermal vents similar to those found in Earth's deep oceans. Ecosystems that thrive without sunlight, using chemical energy instead. The upcoming Europa Clipper mission will investigate these possibilities in detail, scanning the ice, probing for signs of habitability, and seeking the building blocks of life. Then there's Ganymede, the largest moon in the solar system, even bigger than the planet Mercury. Ganymede is unique among moons because it has its own magnetic field, likely generated by a liquid iron or iron sulfide core. This field interacts with Jupiter's powerful magnetosphere, creating auroras that dance across its poles. Ganymede, too, is believed to harbor a subsurface ocean, possibly layered between sheets of ice. Its surface is a mix of dark, ancient terrain and lighter, grooved regions shaped by tectonic activity. Ganymede is a frozen world, but not a still one. Lastly, Callisto sits farthest from Jupiter and is the most heavily cratered object in the solar system. Its battered surface has remained largely unchanged for billions of years, preserving a record of the early solar system. Despite its apparent geologic inactivity, Callisto may also possess a subsurface ocean. Its distance from Jupiter shields it from intense radiation, making it a candidate for future human bases, should we ever venture that far. Together, these moons showcase a spectrum of planetary possibilities: volcanic fire, icy oceans, magnetic fields, and ancient records. They remind us that not all potentially habitable worlds are planets, and that in the shadows of giants, life might quietly stir. At Infinity Beyond, the Galilean moons are a solar system within a solar system, 4 worlds orbiting one, each pulling us deeper into questions of habitability, geology, and life. As we send more missions, capture more data, and one day perhaps even land on these distant shores, we edge closer to answering a question that has echoed across centuries. Are we alone?